Welcome back to Decentralized Application Development Crashcasts. I'm Sheila, and as always, I'm joined by my co-host, Victor. Before we dive in, I want to remind our listeners that if you're enjoying our show, please rate us on your favorite podcast platform. It really helps us reach more developers like you.
That's right, Sheila. Your support means the world to us. Now let's get into today's topic. We're continuing our journey through Chapter 2, Fundamentals of P2P Networks, and we'll be discussing peer discovery mechanisms.
Exactly, Victor. But before we start, I have a quiz question for our listeners. Are you ready?
Oh, I love a good quiz. Let's hear it.
All right, here it goes. In a P2P network with 1,000 peers, if each peer knows about 10 other peers on average, what's the minimum number of hops needed to reach any peer in the network, assuming perfect routing?
Wow, that's an intriguing question, Sheila. It really makes you think about the structure of P2P networks and how information spreads. I'm sure our listeners will have fun pondering this one. It's not just about the math, but understanding how peer discovery and networking in P2P systems work.
Absolutely, Victor. Now let's dive into our topic. Can you start by explaining what peer discovery actually means in the context of P2P networks?
Of course, Sheila. Peer discovery is the process by which nodes in a P2P network find and connect to other nodes. It's like when you move to a new city and need to find friends. You need a way to meet people and build your social network. In P2P terms, it's how a node joins the network and finds other nodes to communicate with.
That's a great analogy, Victor. So why is peer discovery so important in P2P networks?
Well, peer discovery is crucial because P2P networks are decentralized. Unlike client-server models, where all clients know the server's address, in P2P networks, nodes need to find each other dynamically. Without effective peer discovery, a P2P network would be fragmented and inefficient.
I see. So how do nodes actually discover each other? Are there different mechanisms?
Yes, there are several mechanisms, broadly categorized into centralized and decentralized approaches. Let's start with the centralized approach. In this method, there's a central server that keeps track of all active peers. New nodes contact this server to get a list of peers to connect to.
But wait, doesn't having a central server go against the idea of P2P networks being decentralized?
That's a great observation, Sheila. You're right, it does introduce a centralized element. This approach, while simple, has drawbacks. The central server can become a single point of failure and a bottleneck. That's why many P2P systems prefer decentralized discovery mechanisms.
Interesting. Can you tell us more about these decentralized mechanisms?
Certainly. One key concept in decentralized peer discovery is the idea of bootstrapping nodes. These are well-known nodes in the network that new peers can connect to initially. Think of them as the welcoming committee in our new city analogy.
Oh, I think I understand. So new nodes connect to these bootstrapping nodes first, and then what happens?
Exactly. Once a new node connects to a bootstrapping node, it can learn about other peers in the network. This leads us to another important mechanism: gossip protocols.
Gossip protocols? That sounds intriguing. How do they work?
Well, just like gossiping in real life, gossip protocols involve nodes regularly exchanging information about other nodes they know. Each node maintains a partial list of other nodes in the network and periodically shares this list with its neighbors. Over time, this allows information about peers to spread throughout the network.
That's fascinating. It's like each node is constantly telling its friends about other friends they should meet. But I can imagine this might lead to some challenges. What are some of the difficulties in implementing peer discovery?
Great question, Sheila. One major challenge is dealing with network churn. That's when nodes frequently join and leave the network. It makes maintaining an up-to-date view of the network difficult. Another challenge is ensuring that the network doesn't become partitioned, where groups of nodes can't reach each other.
Those sound like significant hurdles. Are there any best practices for addressing these challenges?
Absolutely. One common approach is to implement a hybrid system that combines centralized and decentralized methods. For example, you might use a central server for initial bootstrapping but then rely on gossip protocols for ongoing peer discovery. It's also crucial to implement robust error handling and periodic health checks to detect when nodes have left the network.
That makes a lot of sense. Now, before we wrap up, I think it's time to reveal the answer to our quiz question. Victor, would you like to do the honors?
I'd be delighted. The answer to our quiz question is approximately 3 hops. This comes from the concept of 6 degrees of separation applied to networks. In a network where each node knows 10 others, you can reach 10^3 into 1,000 nodes in 3 hops. This demonstrates the power of peer discovery and efficient routing in P2P networks.
Wow, that's really interesting. To summarize what we've learned today, peer discovery is a crucial process in P2P networks that allows nodes to find and connect with each other. We discussed centralized and decentralized mechanisms, including bootstrapping nodes and gossip protocols. We also touched on challenges like network churn and the importance of hybrid approaches in real-world implementations.
Excellent summary, Sheila. And remember, listeners, understanding peer discovery is key to building robust and efficient P2P applications. It's the foundation that allows decentralized systems to function effectively.
Absolutely, Victor. And to our listeners, we hope you found this episode informative. If you did, please visit crashcasts.com and consider joining our Discord community. Your support on Patreon helps us continue creating this content. Don't forget to subscribe and rate our podcast. It really does make a difference. Until next time, happy coding.